My wife tells me never to start with a bad joke, so I ignore her advice. The kind of paradigm I'm going to talk about today doesn't have anything to do with 20 cents. Yeah, I know. That was even worse than I thought. So anyway, okay. Paradigm argument against Psi. Oh, I can do this with this, can't I? Okay. So why do I call it the paradigm argument? I'm going to give you a little bit of background. Most of this will be familiar, but it doesn't hurt to have a little bit of a review. The term paradigm was introduced into the scientific literature really by Tom Kuhn back in 1962 with his book, The Structure of Scientific Revolutions. And the kind of paradigms he generally is talking about prevalent in science involve the integration of exploration and explanation in the science community. They provide the context of discovery, the form, the boundaries within which science discoveries are conducted or made, actually. They put these boundaries around what is considered to be possible. Direct energies in efficient, organized ways. That's important because there is, no matter how much money the government may give you for research, there's never actually enough, is there? And you have to have some way of organizing your research in order to accomplish as much as possible with it. And paradigms tend to resist departures from established theory and practice. I want to say a little bit more about that last bullet, okay? Because in doing that, they also establish an orthodoxy. Now, orthodoxy has a bad connotation in society today. Everybody thinks that's what we should be getting away from. But in fact, orthodoxy in most cases is useful and valuable. Orthodoxy in and of itself is not bad. It can establish principles that are actually effective and helpful and promote good goals, and particularly in research. However, there are times when orthodoxy gets out of control, and we'll talk about that a little bit later. So, unfortunately, one of the things about that orthodoxy is it does result in kind of comments like this, at least as far as ESP or Psi is concerned. Most of you know of or know personally Richard Wiseman and are familiar with this statement. He says, "I agree that by the standards of any other area of science, ESP is proven. But that begs the question, do we need higher standards of evidence when we study the paranormal? I think we do." Okay, and he, of course, is one of a large chorus of people making the kind of same sort of demand. Brings to mind Marcello Truzzi's extraordinary claims require extraordinary proof. So, why do many scientists find Psi or ESP scary? So, first, it's the old idea, if it ain't broke, don't fix it. Our current scientific paradigm works really well. In fact, arguably, it's the most successful research paradigm ever in effect in the world's history, as far as we know, right? It's amazing what the paradigm overall, the general paradigm, has accomplished in a relatively short period of time in human history. So there's a kind of a tendency not to want to tinker with something that's producing good results. Second, ESP, Psi in general, ESP evidence in particular, seems to violate laws of nature, and that's upsetting. And of course, ESP may itself be evidence of some non-physical phenomenon in the universe, or some non-physical force, some non-physical aspect of the universe. All of that gives some certain scientists a fit of the quivers, I guess you could say. And it doesn't help when the folks who are in favor of ESP and Psi make statements like this. Let's get together and change the paradigm. Let's create a new paradigm. Let's get beyond science. Let's leave all that old fuddy-duddy thinking behind. That's bound to scare scientists as well. And in fact, this in itself is almost as misguided. This whole attitude is almost as misguided as the orthodoxy is in resisting it. And I'll talk a little bit more about that later. Okay, so this is the argument that the paradigm argument attacks. Got that? Okay. This is the one that generally most of us, I think, support. If there is the right kind of evidence for ESP, then ESP must be real. There is the right kind of evidence for ESP, therefore we should accept ESP as real. Okay? It's very straightforward. It makes a lot of sense. Most people think that seems plausible. Why would that be wrong? The paradigm argument, generally specified, goes like this, though. Even if you have good evidence for ESP, there's no explanatory framework for it. If you don't have an explanatory framework for it, it doesn't have its own paradigm. And if it did, it would be in conflict with the current paradigm, right? So you can't explain it. And without that kind of a theory, science can legitimately not take it seriously. So if you have an explanation for it, we'll let it into the club. If you don't have an explanation for it, it really doesn't matter how good it is. We're going to hold it at arm's length. So how many have heard something along these lines from some scientist or skeptic somewhere? Yeah, this, even though oftentimes it's not explicitly stated, this is the implicit argument that is behind many, many, many skeptical arguments against ESP and psi. Okay, so let's go into this in a little bit more detail. First off, a real phenomenon must be in principle explainable. Okay, so I'm just breaking this argument down into its constituent parts. If a phenomenon is unexplainable, there are two possibilities. Either the current paradigm is either incomplete or wrong, or the phenomenon isn't actually real. It's wrong to abandon a successful paradigm just because you have some data that it can't manage. Every scientific theory has some anomalous data associated with it, particularly relatively new ones. And the idea is that science works on reconciling those anomalies with the base theory. A classic example is what orbit was it? Neptune, I think the orbit of Neptune. Whichever one it was, had an aberration in it that wasn't explainable by Copernican theory. It was an anomaly, but with further research they discovered why that was, and it fit right into the model. Okay, it had to do with another planet they didn't know was there. Okay, but just because you have some data that doesn't work doesn't necessarily mean that your paradigm is wrong. Okay, it's more reasonable to reject that data instead if you can't find an explanation for it. And so, since evidence for psi is not explained, in fact contradicts current paradigmatic science, I'll say that very quickly several times, we should reject the psi evidence even if it is scientifically produced. Okay. It's really kind of a plausible argument, but there's this further added thing that ought to be there, which is until such a time as we can either find a way to fit it within the current paradigm or can conclusively prove the evidence is wrong, or of course in the outside possibility that the paradigm is wrong. Right? But when critics of psi and ESP research formulate this argument, they leave that part in, they don't leave that part in, they state the first part of the statement and then they ignore the rest of it. And so essentially the bottom line is ignore the ESP evidence. Okay. So here's an example not of ignoring ESP, but of the reasoning behind this. Okay, so everybody's familiar with the geocentric, the Ptolemaic worldview, the cosmology. The idea the planets and the sun and everything went around the Earth, and because there were some strange movements in the way the planets sometimes seem to go retrograde, they built in these epicycles where it's very convoluted, kind of a complex system, but it worked mostly. And then the heliocentric theory came along, and at first was rejected. Okay, and for a long time it was kind of it was not accepted. The geocentric theory was continued to be promoted and taught, and in fact one philosopher thinks that was a good thing, sort of. He says, for a long time the most rational thing was to keep geocentrism, warts and all. It would have been wrong-headed to abandon geocentrism and its epicycles without its Copernican replacement. So just because you have an alternate theory, if the theory you actually currently subscribe to works better in explaining what you've been able to observe so far, you should keep a hold of the current one, even though you know it may be essentially wrong. And so this is elicited by this philosopher. He says, a false theory with high verisimilitude may be the only hope to guide research. It is better, that is, than no theory at all. Refutation at T requires rejection in principle, but not rejection at T. So in other words, if at a specific time you know your theory is wrong, you're still better off using it until you have something that really does answer the questions. And so under this, this just underlies the idea that if you don't have an explanation for ESP, then you don't pay much attention to it until you do. Okay, So let's talk about replacement theories, which ties right into the previous statement. So replacement theory has to give you better explanatory power than the theory that it's going to replace, or there's no point in replacing it. Okay? And in fact, if the other theory isn't as good, then you're better to stick with one you have. There is no good theory for psi or ESP. Therefore, ESP evidence cannot count against physicalism. And I'm going to elaborate on what physicalism really means here shortly. So, statement from Hales again. ESP is not consistent with either our best empirical theories or with our best philosophical theories about the mind. Keep this quote in mind. It's not consistent with either our best empirical theories or with our best philosophical theories. Okay, and so we should prefer any hypothesis consistent with the accepted paradigm instead. And he gets carried away on this when he says, in fact, and he specifically addresses reincarnation. He says, reincarnation, the non-material, the non-physical view of reincarnation should be rejected. He says any theory that has a physical explanation is better than the non-material explanation. So for example, and he uses this example, let's suppose you have this group of aliens that likes to abduct people and mess with their minds just because it's fun to do, right? And they implant all these false memories and stuff, and then they plug the people back into their society, and the people go around claiming all these things. He says, that may be a bizarre theory, but it's actually better than the non-material version because at least it's explainable in a physical context. There's reason to believe there might be aliens. It could conceivably be possible in a physical way to conduct those kind of experiments. Therefore, even as harebrained as that idea is, it's better than postulating a non-physical, non-material aspect to the universe. Okay. So, I like to add this, and so we should prefer any hypothesis, no matter how ridiculous it is. And we see that oftentimes in skeptical debates. Whoa, I better talk really fast. Okay, where the paradigm argument goes wrong. The first thing is, oftentimes it presumes that the available evidence is trivial. Kuhn talks about in his paradigm research that if you get a big enough body of evidence, you can actually cause the paradigm to be changed. You have a scientific revolution. The folks who argue against psi presume it has, or at least argue that it has less substantial evidence. It has as little substantial evidence as many of the other bizarre kinds of claims about, fringe science claims and such, okay? But the fact is, they're wrong about this. In my own research for my dissertation, I tried to tabulate just 4 different research paradigms in parapsychology. Presentiment, Dean Radin pioneered this. I found 23 studies at the time I finished. There's been a couple more come out since. Of those, 12 were significant, 3 were in a positive direction but non-significant. The rest were not significant, where by chance there should only be 1 successful one. So this shows there's something going on, all right? Direct mental interaction with living systems, 68 studies, 40 significant, 6 mixed bag, 8 positive but not significant, 11 were non-significant, but some of those 11 were actually testing boundary conditions, and they almost don't count as replications because you test parameters that you don't know if they're actually going to work or not, and so some of those were just exploratory. So in chance for this number, you would expect 3, and they actually had 40. Remote viewing, I can't even tabulate it. There's so much material here. In one report in 1988, recently declassified, almost 26,000 trials. Odds against chance of the successful results was 2 times 10 to the 20th. That's 2 followed by 20 zeros to 1 against chance. Of course, the pair trial, 653, and you see that they got a great result as well. And ARV, you heard some about that yesterday. There's even more to say about ARV, but I don't have time. Okay, paradigm argues that science has alternative explanations to psi, and some of those are fraud, flaws, misinterpretation of data. The fact is, if you can discount those, as I think has been done in a number of cases, if you eliminate them, science doesn't have an explanation. So remember, go back to your best theories. The reason there are best theories is because they have ignored the data. And so they remain our best theories because they haven't dealt with the elephant in the room. Okay? Physicalism is different than physics. That's the final problem. They associate physicalism with science, and it's not necessarily the case because, here's physics, the examination of physical entities, properties, and relations and their interactions. Physicalism is the doctrine that everything in the universe is physical, or as a consequence of physical facts alone. They are significantly different in import. So physics covers physical things. Chemistry could be, there's already, through reduction, you end up fitting a lot of these sciences within physics in the greater picture, and that's how I'm going to lay it out here. Biology, geology, psychology, all the other ologies and such, they all can fit within physics. But physics and all of these other things fit within physicalism. So physicalism is kind of an umbrella doctrine that embraces all of these things. It adds something additional to them, okay? So physicalism is a metaphysical claim. It deals with theories about what there is, what is real, fundamental nature of what exists. Okay? It is assertive, it's not explanatory. It states, it specifies, everything is physical. It doesn't give proof of that, it gives some evidence, but the fact is, without knowing everything in the universe, you can't know that everything is physical. And since it's metaphysical and assertive, not explanatory, it's actually not a scientific paradigm. Okay? So what I claim is that accepting psi, ESP, data, whatever, as real requires little change in current scientific paradigms. Why? Okay, so if let's say, because that's the worst case here as far as science is concerned, if presumably non-physical entities exist, it doesn't affect physics. Physics is only about what's physical. It doesn't affect chemistry, it doesn't affect geology. It has exactly no impact on any of these sciences, okay? But it does on physicalism, the doctrine that everything is physical. So here's current formulation. Some things may be non-physical, that's what we think, or potentially many of us think, okay? Physicalism is everything is physical. These are incompatible. However, this is all that physics as a science requires, that some things are physical. It's perfectly harmonious with the existence of psi and ESP. No paradigms need to be changed there. Okay, so here's the model that I showed you earlier. Without these sciences, physicalism kind of loses its force. However, here's the sciences with physicalism. Without physicalism, the sciences remain unchanged. So, as I say here, no paradigms will harm the production of this presentation. Only physicalism as a dogma is threatened, and only because of its universal claim. Everything is physical versus some or even most things are physical. We can live with some or even most things are physical. That's not an issue. And so, okay, how did I do on time? Thanks.
Thank you very much. Those who would like to ask Dr. Smith a question, please come up front and speak into the mic.
I've been trying to get a remote viewer to talk about Spottiswood's findings, and they're relevant right now because Spottiswoode showed that there is a negative correlation between geomagnetic activity and the success of remote viewing.
Okay. Well, we did talk about LST. Has he talked about geomagnetism too?
Yes.
Has he? Okay. All right.
Well, that fits in very, very well with the spikes in geomagnetic activity.
Okay.
And, well, that's all I wanted to point out.
Thanks.
I want to make three brief comments here. The first one is that Stephen Brush has done a lot of studies of people's acceptance or non-acceptance of scientific theories, not necessarily scientific data. And what he's shown is that basically at any given time, there's a whole range of different feelings on the part of people about what theories are true and why they're true, what parts of them are true, and so on and so forth. Really good, terrific stuff, very, very rigorous, and in a variety of different disciplines. The second thing is in the meteorite controversy, which I did make a special study of myself, one of the arguments was we shouldn't accept meteorites unless we can explain them. So as soon as they realized that meteorites must come from the moon, they accepted that.
Yeah.
In other words, the wrong explanation was actually what allowed them to feel good about.
Yeah, even the wrong explanation is better than no explanation at all.
Yes.
Yeah. And that's psychology. It isn't science, it's psychology, right? It's human psychology. You don't want that. Go ahead.
Yes. Yeah. And number three is you should see what happens with the ball lightning people and as they struggle to figure out which one of the dozens of explanations that people have are possibly correct. And it seems to me absolutely ridiculous to reject the
existence of phenomenon.
Observations until you can come up with a decent theory.
Yeah.
I think at the The right thing
Yeah,
to do is to try to collect the observations and then keep working at trying to come up with a
Right,
theory.
and that's the problem. It's not important that they accept that science and the skeptics accept ESP data is relevant, but they also quash research into it. That's where the real problem lies. They don't allow you to look into it. Okay, sorry. Am I done? No, okay, good.
Thank you very much for a great talk. I really loved your conclusion. In the middle, I was starting to go nuts because some of the things that you were saying directly contradict my training in science, which is that although science is an interplay between empiricism and theory, it has to be driven by data. And so if the data are reliable and reproducible, theory has to change in order to accommodate that and not have the data be thrown away because the theory can't handle it. So physicalism borders on an ideology or even a religion rather than a theory because it's not responsive to the data-driven nature of science.
Right. Of course, whether theory or data drives the train depends on which school of philosophy in science that you adhere to. There's arguments between both directions. Go ahead, York. I'm almost scared to hear this one. Go ahead.
Actually, I just wanted to ask if you had noticed that the various theory-driven arguments you were presenting that you've obviously run across in your research really have a strong isomorphism with the scientific creationist justification for discarding fossil evidence because it conflicts with the literal truth of the Bible. It might be useful for polemical purposes to point out to these guys that they're behaving exactly like creationists.
You know, in my dissertation, I actually, talk about, in ID, there's this idea of the God of the gaps, where, we don't have evidence of God in certain areas, but there's probably some hiding out there because we don't know everything about science. And in fact, really, the skeptical side uses the same kind of gap argument to justify many other claims. So yeah, you're exactly right. Thank you for not scaring me to death there, York.
Yes, Paul, I wanted to ask you, what your thoughts were on the fact that current Orthodox scientists and physicians reject Psi because it doesn't have an adequate theoretical explanation, but yet they demand in medical research that all medical research be conducted with randomized placebo-controlled trials, even though the placebo effect has never had an adequate explanation or a theoretical basis. So what are your thoughts on that? It's kind of schizophrenic almost within the...
It doesn't have to be rational, does it? Yes, that's what. Of course, now that's practical science. It's application science oriented in that case. And when you start dealing with the real world, oftentimes the theory gets a little fuzzy, and they start going with what works than necessarily what's doctrine. By the way, if any of you have some great quotes that support the paradigm argument, I'd love to have them. I want to collect all of the quotes and such about that. So anyway.
All right, Paul, thank you very much.
Thanks.